Hello, my name is Nadia Salou Doudou. I'm a senior undergrad student in the computer science department. Today, I will be presenting about my research project, which I have started this semester under my supervisor, Dr. Shanzhuang Zhu. So, a little bit about my research. In recent years, graph neural networks have gained great interest and have obtained influential results in various analytical tasks including node classification, community detection, and molecule generations. Although similarity among entities may be represented as pairwise relation in graphs, in many real-world problems it is necessary to model higher order relation between subsets of objects via hypergraph. And in the next slide, we'll be seeing the difference between hypergraph and simple graph. So new techniques are being introduced to the hypergraph neural network family in order to efficiently perform machine learning over hypergraph. However, this algorithm focuses only on proposing and testing a particular architectural design of hypergraph neural networks for a single task or dataset. And the problem is this algorithm may not work well for novel tasks or datasets. So as stated in the previous slide, here we have the main difference between the hypergraph and a graph. On the left picture, we can see what a graph looks like, and on the right picture, we have a representation of a hypergraph. So the main difference is that a graph just connects two nodes. It can be more than that. However, in a hypergraph, we have more than two nodes that are being connected. It can be three, four, five. Just it would depend on how the relation or the connection would be. Moving to the goal of our research. So our main objective through this work was to study a more general architectural design space. That is to say, we wanted to be able to automatically search an effective neural network architecture for a given new task and dataset, as doing so will help us to reduce the amount of time that will be spent in trying to find the most effective model for a dataset. Further, we plan also to explore a task space for hypergraph neural network that will enable us to categorize related tasks in order to quickly define a model for a new task based on its similarity to previous work. Also, I wanted to mention that our work is based on a previous work done by Jiansong Yu, Reg Ying, and Jure Leskovic in their published paper titled Design Space for Graph Neural Network, which I will be adding the link for the paper in the GitHub repository in the description below. Here comes one of the most important part of the project. So in their work, Leskovic and his colleague developed a platform called GraphGym, which will enable us to quickly determine a model for our dataset. Therefore, we wanted to incorporate three dimensions in their work and establish our work. The idea was given a hypergraph of a dataset, we convert the hypergraph to a graph and apply the corresponding graph neural network model. To do so, we have three methods of conversion: the click expansion, the star expansion, and the hyper-GCN. The first method is the click expansion. So in graph theory, a click is a subset of vertices in a graph such that every two vertices are connected. Therefore, that subgraph is a complete graph. So based on this definition, the idea here is for every node U and V in each hyperedge, we would add an edge between U and V so as to obtain a complete graph from the hyperedge. The next method is the star expansion. A star graph is a graph which has a central node that is connected to every other vertices in the graph. So each vertex in the graph has a degree of 1 except the central vertex, which has a degree of n minus 1 given n vertices in the graph. Here again, using the definition, the idea is to introduce a new node V such that for every hyperedge, the node V will be connected to every other node in the hypergraph. So lastly, the method that the third method was the hyper Laplacian method to convert a hypergraph to a simple graph. That is, given some real value signal, we'll consider the two hyper node that have the maximum signal difference to form a pairwise connection. So here is it about the methodology, and moving to the result and discussion. Unfortunately, our work is still in progress, and as for now, we do not have a result for our experiment. Once a result is obtained, hopefully sometime soon, we'll be comparing our work with other models for a qualitative analysis, as we can see in the picture below. So that is it about my presentation. Thank you so much.